Well, it's not like you all haven't been warned. We've been talking about 2023. I picked that as a year that would be telling in terms of the radiation from the sky. We've already discovered the changing of the particle counts. Some particle counts are measuring particles in nonsensical units, like particles per centimeter or particles per centimeter square, and or particles to the minus cubic centimeter. When we look up the average particle concentrations throughout the solar system, we see that the solar system, I've showed you this before, averages around 4 to 10 particles per cubic meter. But now we're measuring billions of particles per cubic meter, it appears. And so when we have particle densities at their highest levels ever, and then the sun at the same exact time goes into solar maximum, which is we get more energy from the sun hitting Earth. Most of our ice melts, our biggest ice melts, used to historically occur during solar max, and we would get ice gains during solar minimum. Makes perfect sense. We started losing ice during solar minimums. And that happened in 2007, 2008. Look it up. We had epic ice loss during a solar minimum. That means the writing was on the wall. But what I've been saying is we got to be careful. We have to prepare, not only for what the solar system is going to do to us, but for what mankind has in store for us. I don't know what mankind has in stores for the United States. I don't know what mankind has in store for Africa or South America. But by the same token, it's kind of hard to plan for food shortages and then for forced depopulation and involuntary detention, which are conspiracy theories. But everything that conspiracy theorists have been saying about that stuff, a lot of the other things they have been warning us about have been happening, and have been happening almost in lockstep to those predictions. Former employers, former employees, former investigators. These people are whistleblowers and are coming out of the closet because they're getting older, they've had a good life, and they don't want to go to their graves being the evil one. Now, what's happening in Fredericksburg, Virginia, West Virginia, is a magnetometer there that measures the strength and the state of our magnetic fields. During a geomagnetic storm, we see a lot of red bars on the graphs, which are considered a geomagnetic storm in our own magnetosphere. But something weird happened on October 21st. October 21st, Fredericksburg measured a geomagnetic storm that was, quote unquote, off the charts. Rarely does this happen ever, but rarely does it happen just on one magnetometer or one measuring device. But then came the following week. And in that following week, from the 25th through the 31st, we had periods where Fredericksburg was measuring some of the most intense geomagnetic storms ever recorded in modern history, especially in the number. And I find it ironic that many of the other magnetometers were showing just the opposite. They were showing very low level activity. When you go to the Fredericksburg website, there were no disclaimers. There was nothing about how they were having measurement problems. And generally, when you have a device that measures something, when they do have a problem, the device under measures and under reports. So having something that over-reports is extremely, extremely unusual and very, very rare. But there they are. Geomagnetic storms off the charts. So you have to ask, what's going on? What's going on? And because this is the day I've been warning you about, where we get so many particles that our magnetic field is in constant disturbance. When our magnetic field is in constant disturbance, then those particles get through. Now, neutral helium gets through no matter what, because it's impervious to magnetic field. And generally, neutral helium will collide with something in the ionosphere or lower atmosphere. But nonetheless, what is going on? So we turn to the NOAA report on geomagnetic storms, and of course they're there to report the solar flares, and they also tell you, and have been telling you, and I hope they continue to tell us, that the geomagnetic storms and the unsettled state of the magnetosphere has been relatively constant. How is it constant? They call it a disturbance or unsettled. They use terms like that. But predominantly what should stick out is when they tell you the electron flux is high and the proton flux is normal. How do you get a high electron flux and low protons is a mystery to me, because on the sun the electrons come from those protons, and it starts out as hydrogen, one proton per one electron. When it ionizes, you can only get as many electrons as you have protons. So there should never be an imbalance of electrons to protons. But there it is, again and again and again. But seeing them say this, seeing them say high electron flux, normal background protons, is nothing new. What is new is what's happening on the Fredericksburg magnetosphere. And so that, it opens up to many questions. What is going on? Well, we can theorize, but let's just keep going to the instruments. So during that time, we saw incredible fluxing in the densities. High density, low density, low density, high density. And it looked like an EKG monitor. The electron temperatures were surprising to me, because normally the electrons coming from the brown dwarf or electrons coming off of helium generally aren't that hot, because the particles coming off the brown dwarf aren't that hot. You're looking at 10,000 degrees Kelvin leaving the brown dwarf. Well, if that brown dwarf is 4 or 5 AU from the sun, you're going to experience significant cooling by the time it gets to here. Whereas anything coming from the sun is just 1 AU. But the anomalies are still there. The speed is tracking density, which never used to happen. It used to be an inverse relationship. Density goes up, speed goes down. Density goes down, speed goes up. But this, you see in yellow, the speed has been rather fast. Well, and rather hot. So, what we are seeing now is the transition phase of what I've been warning you about. The coronal host streams are coming off the sun. They're combining with the particles coming from another direction, various angles, by the way, not just oppositional, but the sun's wind is a spiral, so it doesn't come out and radiate like a shotgun. Unless there's a CME, a solar flare, then you get a shotgun pattern of particles. but you're getting a stream like a sprinkler that's traveling in a circle. That you get a spiral, and so but the wind coming in is coming in from a lot of different directions, but it's coming straight in. So what we see is a mixing of those particles, and we see almost a harmonic mixing, meaning a regular pulse. So that kind of gives us an idea of from what direction the majority of the particles are coming in. And it's coming in from right where we think this brown dwarf fragment resides. Some people call it Nemesis. Some people call it Planet X. I'm telling you right now, Planet X is not inbound. And and you think the further away it gets, the less harm it can do. But the problem is think of it this way: it's spraying particles in all directions, and every single one of those particles gets pulled back in towards the sun. So they all travel towards a focal point. So then you get higher concentrations the closer you get to the sun. You get higher speeds the closer you get to the sun. So when the sun's wind is spiraling and it's meeting opposition against the second wind, you will see regular fluxes, but only when this brown dwarf is positioned directly at the right position to where these spirals open up and create a little gap in that resistance that they exert upon the incoming particles. But what we are seeing right now is more and more energy, more and more particles coming off the sun. Now, why would we have more coronal hole streams as we go into solar maximum? Why are there more? And the answer is quite simple when you understand that the active regions or sunspots, those active regions tug on the plasma. Float some magnetic flakes on top of oatmeal, and then drop a strong magnet in the middle of the oatmeal. Some of those flakes will gravitate towards the magnet, and some of them will be too far away to gravitate. So that'll create a hole, a seam in the surface plasma of the sun. When that happens, the helium, the hydrogen, and the electrons come pouring out. Kind of like when you separate the curd on a milk, hot milk. When you separate the curd by whatever forces you want to exert, you separate the curd, what comes flying out of the milk? Steam, particles. So, and at high speed and high temperature. So we're seeing a constant stream of high temperature mixing with lower temperatures, giving us a lower average from the sun, but a higher average coming from the brown dwarf. And that's where the temperature has been hovering. We used to see temperatures below the line it's at now, down below that line. That line is 10 to the 5 Kelvin. So 10 to the 5 Kelvin down to 10 to the 4 Kelvin is 10 to the 4 Kelvin is some of the coolest wind we get off that brown dwarf. But then, so we're kind of figuring out what's going on. The magnetometers aren't agreeing with one another, and they're still not. So we go to into November, early November, and now we start seeing stronger magnetic storms coming on the different magnetometers, while Fredericksburg is soft. So, one thing I want to do then is go look at, something that may not be so censored or smoothed out, and we go to some of the magnetic fields, because we have a bunch of satellites up there measuring the magnetic field, and we see during the Fredericksburg event, we see an extremely chaotic magnetic field. It settled down for a few days and then became chaotic again. When we look at the actual magnetosphere during that time frame, we see belts and rings and all kinds of colors on the simulation. This simulation, ladies and gentlemen, measures energy. So look at the Earth in the center. Look at all the new belts. Look at all the new rings. Look at the color of those rings. And you see a lot of energy going around where Earth is. You see a lot of you see a yellow line, and then towards the tailstream where the particles get focused, you see the red, the higher energies. You also see higher energies at the bow compression zone at the front of the simulation. So if the wind's coming in from the sun right to left and meeting or merging with wind coming from at a slight angle, then you're going to get a mixing of particles that's rather well mixed, because these particles are no longer in opposition. And you're going to get fluxing. And so the energy is created when the helium runs into electrons, when it runs into protons, especially the helium-3. Helium-4 is in greater abundance and is neutral. Helium-3, though, is a little more reactive because it wants another proton. It wants another helium. It wants another electron. So it can react more quickly to the solar wind than does helium-4. But this measures energy. It measures energy in joules. And I don't mind telling you that the volume and the amount of energy being measured, the scale has changed on this graph. The numbers have changed. And to me, the numbers were changed to soften the appearance of the simulation. Because if you raise the bar, then you don't reach the bar as much. And when you raise the bar in terms of what you are measuring, then everything looks low compared to your new bar. But that new bar is high. And so you may be getting the same amount of energy as you did 10 years ago or 6 years ago during solar minimum. However, when that happens, when you raise the bar, you could get higher energies and not even notice by looking at the simulation, unless you go back and look at the actual units being measured. Well, this one always measures in joules. So the joules hasn't changed. What's changed is that barcode. That's what's changed. And we made a video about 5 years ago showing you that exact change in that bar. That they raised the units being measured so that the color doesn't go all red on you and freak you out when you look at the simulation. But ladies and gentlemen, Earth is in a ring of energy. It's yellow. That's pretty high energy being created in the magnetosphere. Also, the surplus electrons. Electrons are the biggest creator of energy. They're the biggest disturbers of the magnetic field. Why? Because they're magnetic. So you want to change your compass. You want to change, what's happening with a magnet. Introduce, bazillion electrons into the system and see what happens. Everything changes. So, and electrons give off a vast array of energies. Just a normal flow of electrons, of even low energy electrons, just a stream of them alone creates electromagnetic energy. Move a compass near an extension cord that's plugged in and running running something, running a current through that extension cord, your compass will shift because that wire is giving off an electromagnetic field. But then if you do things to the electron, like change its direction, collide it with something, and it collides with everything. It can collide with a photon. A photon is a particle of light or a beam of light. That'll release gamma radiation. Changing the direction abruptly of an electron changes the energy it gives off, and also can create gamma radiation. Changing the energy levels of electrons releases X-rays. In fact, the background X-ray glow that you've always heard about in astronomy in the sky is created when protons lose their electrons to helium-3, or when protons steal an electron from helium-4. Because protons are giving and taking depending on their temperature. The hotter the proton, the less likely they will attract electrons. They will shed their electrons. That's called ionization. So what you're seeing is collisions, changes in direction of electrons, and 90% of the energy you're seeing is electron generated, because we're still shooting electron jets, pulsing them into the tailstream. It is still happening. And I've shown you that, what, 1,000 times now? So to me, it really appears we're going to get more electrons. Why? More coronal hole streams, period. And remember, coronal hole streams run fast and hot. And helium is generated. Now, what happens when helium-3 collides with helium-3? Well, it forms more complex molecules of helium. Anytime helium changes its, its structure. If you go from helium-4 to helium-2, helium-4 to helium-3, helium-3 to helium-4, all of those reactions give off radiation and gamma radiation. But here's what they're not telling you. And I read this to you from an article. I found it buried in a NASA article. And I read it to you. I quoted the article. The ionization of helium releases 250 times more energy than the ionization of hydrogen. That's astronomical. So if you already have billions more particles per cubic meter of helium, when that helium hits the sun is just going to start glowing. And that is why the sun is hot, the sun is huge, the sun is cooking you, the sun is bleaching the coral. That is what is going on. Then you talk about the particle collisions, you're talking about gamma being released off the coronal. And you talk about electrons colliding with various things. You're talking about gamma. You're talking about electrons being redirected suddenly. You're talking about gamma radiation. When a photon strikes an electron, it's called the inverse Compton effect. So well-known thing. So when you go get X-rays, when you go get radiation for cancer, you have a lot of times a particle accelerator. And in some machines they'll say, well, we can do electron beams or we can do proton beams. Well, to me, if I want to kill cancer, so it's, the electrons release radiation, period, and various kinds of radiation. Now, I went to the X-ray flux monitors. X-rays look to be smoothed out. I can't imagine that our background X-rays aren't going up. We've been covering the increase in the background radiation, background X-rays. They've been going up. They've gone up by a factor of 10. And sometimes even more. But for them to settle and stabilize and plateau where they are does not fit the model that we're worried about. We're worried about record number of particles being present around Earth, not out at the heliosphere, not at the bow shock zones, but being a record number of particles in the Earth matrix. And then the sun going into solar maximum. That's a lot of radiation we're going to be getting. We're already getting. I mean, if background X-rays are up by 10, I mean, you should be running up to the mountaintops and screaming to the people. Background X-rays up tenfold. Tenfold. I mean, think about that. Think about going and get a dental X-ray on your tooth. And instead of just taking one X-ray of the one tooth, the dentist takes 10 X-rays. Unnecessary, but 10 X-rays. Then he goes to another tooth, takes an X-ray, and then does 10 more X-rays of the second tooth. That is what's happening in your world. But I'm not seeing it in the X-ray charts yet. So stay tuned. Be prepared. Keep following this channel. We're going to follow this until we're gone. And I could be goner sooner than you think, due to medical things. So I feel attacked, actually, but I can't prove it. But I wouldn't be the first one. So thank you again for your support. Thanks for hanging on to me. And every time I make an offer to give back to somebody, every time I do something special and make a promise, immediately something sabotages me. COVID was a huge sabotage. I mean, how do you ship off quality product when you can't even get a quality container? I mean, how do you do that? And then I get COVID when it's at the lowest it's ever been since COVID started, when I'm going to a place that's low risk, when I take all the precautions and I still get it. Yeah, I feel like I was bioed. And there are doctors who claim they've been bioed. There was a group of doctors, 10 to a dozen doctors and experts were giving a conference in Colorado. And they all got sick on the same night. You tell me what happened.